When you work in software, you might find that the people around you, clients, friends, bosses, loved ones, etc., might ask you a question like, so when's it going to be done? And I think that done in software is a tricky subject. And I think it is best framed in terms of Lehman's laws of software evolution. So that's a thing, paper from the 70s by Meyer Lehman and Laszlo Belatti. I'm not too sure why only Lehman is the only one who gets credit for the laws, but c'est la vie, I guess. So there's a typology in there where there's three kinds of program. You've got S programs, which are conformant to a spec. So, like zip and unzip would be an example of that. Gzip, ungzip, whatever. Like just compression algorithms. Like just those programs they conform to a spec. You write them to the spec, and they're done. A P program is a program that might use multiple strategies to solve a problem. And you can kind of think of a P program as a sort of a union of a bunch of S programs. And then finally, there's the E program, which is a program which is situated in an environment. And that's like more or less like actual software products that people use in pieces of infrastructure and so on. And the environment constantly changes, and therefore the software has to change indefinitely. And so that really is kind of, to me, that's like an excellent kind of a framing, because you take an S program, you write it against the spec, you test it against the spec, okay, it works, it's done. You don't have to go back and mess with an S program unless it's got bugs, or if you want to make it more efficient computationally or something like that. Otherwise, S program, you can once and done. A P program, I would say, is basically the same characteristic as the S program, with the exception that you might want to add a new strategy, like effectively add a new S program as like part of its sort of rubric of strategies to solve whatever problem it solves. And that's kind of like, so the quintessential P program is like a chess program. Or to use the compression example again, you can imagine this sort of general purpose compression program that detects what kind of compressed file it is and uses the right algorithm or whatever. So, you've got this potential that, again, it's like bugs, efficiency, and then maybe you're going to add a new thing to it. And then finally, the E program, E programs are never done. Not in any meaningful way, because like unless they, when you sort of think about programs that aren't around anymore, they're just not like, the company went bankrupt, they're not maintained, they were replaced, whatever. They generally just stick around forever, and they're situated in an environment, and they're never done. Now, of course, the thing to recognize is that an E program is made up of S and P programs, and those can be done. And so you can talk about, and I have talked about, like the extent to which a program, a piece of software has this or that capability or is serviceable for this or that objective. And it's, basically fractal. And so it's funny because when, and I'm finding this when I'm working on Intertwingler and I'm working on the IBIS tool on top of Intertwingler. And of course, ironically, the IBIS tool, again, I don't have a name for it, but ironically, it is supposed to figure this exact thing out. But you have some kind of a goal, and then the goal has a bunch of issues that need to be figured out recursively all the way down. And so it's kind of like, well, I'm going to be done this thing, but then then there's another thing that this is a piece of, and that's a piece of that, and that's a piece of that, and that's a piece of that, and so on. So I like to think about, the E programs, and this is of course terminology that you don't need to share with normies, but the E program is the program that the normies care about. They don't care about the S programs and the P programs. They only ever care about the E programs. And those are never done. But what is done is discrete capabilities or goals or serviceability. Is the thing serviceable for X goal, which again is effectively, it's not exactly the same thing as a capability, because you can imagine like software has this capability, sure, but like, does it have behavior that like is incredibly onerous to make it to use it? So serviceable is a very subjective concept, but I would characterize that. So that's kind of like an outside in perspective of like, can I use this to do the thing, or is it worse than not using it to do the thing? And those can be done. That can be done in the meaningful, ordinary, colloquial sense that people use the word done, as in like discharge from your obligation, done. Like, we don't revisit it later, sure, but like, it's done, pay me kind of done. Anyway, gonna finish my coffee.